Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to do test classification with machine learning. Right, so we're trying to see how to use the Udemy dataset that we discovered, we explored previously, to be able to build a predictive model that can be used to assign tests, right, to their predefined categories. So that is the basic understanding behind test classification. So our task is to predict the subject or category of a given course title, right? So that's what we're trying to be doing. So this is going to be our simple workflow. We just do some simple EDA. We'll build our features from our test using TF-IDF. Then you build our model. You work with a single approach and a pipeline approach. Then you also see how to evaluate our model, interpret, and then productionize. So let's see what we'll be doing in this wonderful tutorial. So apologies for every noise you'll be hearing behind. Okay, so let's see what we do. So we'll be loading our EDA packages. So we'll be loading pandas and then need test to help us clean our test. We'll be loading our data visualization packages, which is going to be Seaborn to help us visualize some simple stuff. Then from here, we are going to also import, we'll be importing logistic regression and then multinomial from naive Bayes to help us with our classification, right? Very simple. So let's see what we will be doing. So I'm going to load my dataset that we have. It's going to be my df pd.read_csv. My dataset is inside my data folder, which is called the Udemy dataset, right? So that's what we're trying to do. Perfect. And then from here, we will just explore it out. So if I check it out here, we have several columns from this dataset. We have the title column, we have the subject column. So this is what we used previously in doing the recommendation step. So we're picking the same course title together with the subject category, right, or the subject and the category column, to be able to predict the class, right? That is the basic understanding. So let's put everything together. So let's check for the shape of our dataset. So df.shape to see the size of our dataset, which is quite a lot. Then I'll come back again and I'll check out what you want to do. So we are just picking the course title, and then you're also picking the subject. So these are the two main things we are picking, right? So we are picking the course title and the subject. The rest we are not going to use. So we are using this one to predict this particular class, right? So let's see how to do that. So first of all, we'll be doing some simple test cleaning. So we're trying to clean this test of every special characters and then unnecessary characters. So this is going to be my test preprocessing. So what we're trying to do, we're going to be reducing every noise within them, and the noise can be a punctuation, right? Perfect. And noise can also be special characters. Noise can also be stop words, right? So that is what we're trying to do. And sometimes in test processing, you can also do lemmatization, where you're trying to get the lemma of a word, and can also do stemming, right? Which are two different concepts but having the same approach. Very nice. So that's what we're trying to do in this particular part of it. So let's see how to first of all reduce the noise from them by removing special characters and then stop words. So we're using neat test to make our work easy for us. So let's preview neat test to NFS. So we have imported neat test already. So with neat test, you can do a lot of cleaning activity. You can extract whatever you want: currency, stop words, date, email. With neat test again, you can also remove special characters, remove custom words, remove emojis, emails. You can also remove these ones. So we're removing these particular ones, right? Special characters and then stop words. You can even remove short words. Okay, let's come back and see what we're doing. So I'll come back again to my dataset, my df.course title. This is what we have, and I want to remove stop words. So it's going to be my same thing. So apply. I'll pass in my function nfs.remove stop words, right? So that's what we're trying to do. So I'll equate this particular stuff we have. If I run it, it's going to remove all the stop words, and as you can see, there are no more stop words. So how to maximize for the initial one, there's no more there, right? As you can see. So I can just come back again and equate it to the clean course title, right? And I'll equate this one to this. Perfect. So if I go back and I check this one out, what we have done so far. So let's do it this way. It's a simple way of doing it. I don't need to type everything. But and I'll come back again. If I check this one out now, you can see the difference between the one that is clean and the one that is the original one, right? And as you can see from here, you can see that how to maximize, right? How to maximize is gone. How to maximize, the how to is gone. Beginner 2 is gone, right? So you have seen how to clean it. But let's also remove special characters like these ones from it. So in doing so, you can just come back in and let me copy this one here to save us time. I don't know whether my audio is becoming better now. I hope it's becoming better. Right, clean course title. if in case you have any suggestion of a good microphone that you can use, you can let me know in the comment section, right? Okay, perfect. I can come back again, and I'm going to remove special characters. Right, so it's going to remove all special characters from it. And if I check it back again, if I go back and I check it out, now all the special characters are all gone, right? Perfect, right? So the special character that we had here, right, is gone, right? All of them are gone. So let's do another stuff again. It is very important. Sometimes you can reduce all the text into lowercase. So let's reduce the text into lowercase, and it's very simple to do. You can just go back with string, then to lower, right? So that is how to reduce it to lowercase. So this is going to be reducing to lowercase. Let's put some comment there, right? And this one is going to be removing special characters, so that in the future I can have it. So this is going to be remove special characters, and the first one above is going to be removing stop words as the name. So remove stop words, right? So that we have some comment on it. We have already done it, but let's do it again. Come back again, run everything again, because perfect. Now let's check it out. Okay, so if I go back and I check it out, everything is working as expected. Perfect. So you see that now it is in small case. I don't know why it's failing. Let's run it again to lower, and then let's check it out. Perfect. So now this is in smaller case and this is in upper case. Perfect. So we are done with our test cleaning. Now let's move on to how to build features, right? So it's going to be our building features from the test. I have a whole video tutorial on doing this thing in depth, so you can just check it out in the links below. So let's see what we're doing. So we're trying to convert our words. Convert words. Most ML algorithms don't understand tests, so you only understand numbers. So you're going to convert the words to vectors of numbers, right? That's the only thing that's going to help us understand. We can do that. There are several ways. You can use TF-ID, you can use count vectorizer, you can use hash vectorizer. There are a lot of things. You can use bag of words. There are a lot of things you can do. So we'll not be going to that. So let's just check with the TF-IDF. So using TF-IDF to help us with that, so I have to first of all import TF-IDF. So from sklearn.feature extraction .test, I'm going to import my TF-IDF vectorizer. And so that's what you're trying to import to help us with our stuff. Now I'm going to pick my S feature. I'll call that my S feature, which is going to be the clean course column. The next one is going to be my Y labels, which is going to be, see how I spelled it, Y label is going to be my df.subject column. So this is going to be our category. Perfect. Now I'm going to convert this S features, right, into vectors, right, of numbers. So we can do that with TF-IDF vectorizer. I'll initialize it, estimator. So in building features, right, or in working with circuit learning, doing machine learning activities, there is converting data to data, right, and then converting data to model. So this is what it means. So in case you are trying to build ML pipelines or data pipelines, we have two main concepts. You have data to data, right, and then data to model. So data to data means that you are using a transformer. So a transformer is a function that takes in data, right, and then fit and transform that data into an augmented data or a feature, right? So in case you have standard scalar, TF-IDF, all of them are transformers. So they take in data, then they produce a different format of data. An estimator, on the other hand, is a function that takes in data as input, it fits it, and then produce a model, right? So that is data to model. So all the ML algorithms, logistic regression, naive Bayes, KNN, all of them are estimators. So we're trying to see how to use transformers and then estimators in this session. So let's go back and use our first transformers, which is TF-IDF. So we're going to take this, our S features, which is test, right? It's a data. We're going to take this S features, which is test, which is a format of data, and transform it into a different format of data. So TF-IDF vectorizer, right? Perfect. And then from here, I'm just going to go TF-IDF, I can't spell, TF-IDF vec, right? I'm going to fit, as I said, it's going to fit it, then transform that particular data into another format of data, right? So feature. So I have to equate it to x, right? I'm equating it to s, so it's transforming it into a different format of data. So if I check it out, it's going to give us a sparse matrix, which is just numbers, right? And in case I want to see it out, I can just go back to s.toDense. So the first one is going to give us a space matrix or sparse matrix, right? In case I want to get all the dense matrix, this is going to be this particular format. So in case I want to see the actual test and then their vectors, I can just come back again and let's convert it to data frame. Convert to data frame df by going with my, let's call that my df.vec, which in this case is going to be my pd.data frame. We are using pandas data frame. I'm passing my s to my dense value, right? That's what I'm passing in. I'm going to also pass in my columns. So my column is going to be my TF-IDF vec dot get feature names. Feature names, right? It's a function. So that's what it's going to do. So it's going to compare them, and then if I check it back again, so df.vec, because now it's going to give us not just the numbers but the actual test, right? And you can see from here that this is 0, 0, 0. It's converted them into vectors of numbers, and then these are the actual ways and then their representation. You can also do this option, so t transpose it to see it all, right? So if I go throughout this, all the ways and then their vectors, right? Very simple. So we are done with forming features from our test. Now let's move on to building our models, right? So be building our models. So in building our models, there are two main approaches. You can use a single approach, or a single approach, which you do everything step by step approach, or you can also use a pipeline approach, right? So let's see how to work with the first option of using a single approach. So what you'll be doing, that you'll be doing everything separately, right? But this one, you're going to combine them together. So we see the first option and the second option. So let's see how to do that. So first of all, let's split our data so that we have something to be able to test it. So it'll be from sklearn.model selection. I'm going to import train test split. So import train test split. So that's what I'm importing to help us split our data set into two. Then I'll just come back again and work on it. So it's going to be my s test. We have my s train, my y, the s, and then the s test, right? Just splitting them into s test and then y test. So y train and then y test, right? And from here I just go with my train test split, right? I'm passing my s features. Yes, I'm now passing the x, not the s features, right? That's what they're trying to split. And I'm passing my y labels. Now I want to specify the size, so test size. So the test size is going to be 0.7. That means 70% for my train and then test, right? So that is the basic understanding. So you can actually make it 30, 70 or 70, 30, anyhow you want it to be. It's still going to work. So let's make it there. So it can be 70, 30 or 30, 70. Let's make 30, right? So it's going to give us a test size of 30. That is what we're trying to do. Then we can also specify a random state. So at any time you also run it, you're also going to get the same value. So this random state, that if I run it here and you also run the same thing, data that you have, you're also going to get the same number of splits and then the same amount of data, right? So if I go back and I check it out, so the train, the shape now, going to give us a different shape. Perfect. So you see that this is very huge. So these are all the features that we have, which is 2, 3, 5, 6, 4. All the features is there. Perfect. So that is how to split our data set. Now let's move on and then build our model, right? So we'll be initializing our model. So I'll be using logistic regression. So I'll call it as LR.model, right? Then you can also use naive Bayes, so logistic regression. This we imported from scikit-learn. Right, then I'm not going to pass in anything, so lr.model.fit, right? So this is an estimator. So an estimator taking data as input, then fit it, then it's going to produce a model, right? So I'll pass in my s train and then my y train. That is something very basic. It's going to analyze it and give us our result. Take some time for it to analyze. So after that, perfect, that's finished. So after that, what I'm going to do is that I'm going to be getting the accuracy of it. It's going to be very simple. It's going to be my, can just go straight away with this option. So LR model dot score, right? Then you pass in the S test and then the Y test. So this is another way of getting the accuracy of the model. You can see that it's going to give us 0.95, which is very, very high, right? That means it's highly accurate. Like, it's very close to accuracy. So you are supposed to not just build a model, check the accuracy, you should also check some other metrics. So we'll be trying to see how to evaluate our model, right? So we'll be using there are a lot of tools to allow us to be able to evaluate a model. We can use confusion matrix, we can use cross validation, and a lot of things. So let's see the simplest one. So using classification tree. So it's going to be my from sklearn dot metrics. Going to be important whatever thing I want to use to help us evaluate our model. So the first one is that we can also use classification report, which is only for classification problems, not for regression problems. Then we also have confusion matrix to help us also determine the true positive and then true negative. Then we also have the plot confusion matrix. There are a lot of things you can do, but let's pick these ones. Perfect. So let's check the confusion matrix first, right? So the confusion matrix allows us to be able to know our true positive, and then our true false positive, because sometimes something may be predicted right, but it may not be the correct one, right? And then etc. So let's see how to do that. So it's very simple. So before you do that, you just first of all have to have your true predictions and then your true results, right? And then your predictions. So it's going to be my Y prediction. So this is going to be what the model that I've built is going to predict. It's going to be my LR model, not predict. I'm going to pass in my S test, right? Perfect. That's going to be the first thing. So this is going to be my predictions from the model. Then this is going to be my initial true results, right? Perfect. So I'll just go back again, go with my confusion matrix. Then it's going to take the Y predicting, the predictions, as well as my true values, right? So if I run it like that, now it's which is going to be, this case is not true, this time it is test, because that is our true value. You can see that it's even this number, right? And then you cannot understand this number well, because the reason is that we have, I think, 4 different categories. So df.subject.unique. If I check it out, we have like, these are the categories 1, 2, 3, 4, right? So you have 4, so that's why it's having 1, 2, 3, 4. So it's giving us 4 different true, positive, false, negative, and all of these things. So in case you want to see it very well, you can just use this particular option of the plot. So we can just go with the plot confusion matrix. Then this is going to take the model. So it's going to take the model that we have, so which is going to be my LR model. Then it's going to take some other stuff. So it's going to take the S test, right? My S value, right? It's going to take my Y test, which is the true values. Then if I run it like that now, that is also going to plot it perfectly for us. So the model, the S test, and then the Y test. So this is better. Oh, come back again. Okay, let's go back. Okay, let's close this one and let's go back to what we are doing. If I come back here, so this is going to give us a very nice plot, which is the same thing we have here. The same thing we have here is what has been plotted here, right? Which is quite cool. So 382, 382, 144, right? Very, very nice. So this is the same thing. So this makes it quite easy for you to do whatever you want to do, right? In case you don't want to be seeing this is not nice, can just come back again and go with my S text, right? Rotation, you specify the rotation. Let's specify the rotation as 40, which is going to put it in a better format so I can see it well. Perfect. So this is how it is. So it's going to compare the finance, right, with finance one on the true labels, and it's going to be the predicted labels, right? So it's going to give us a false positive and a false negative. That is simple explanation of it. Now we have done with simple confusion tree, but can also get more information using the classification report. So that's going to be my classification report. The classification report is only for classification. It's going to give you a more in-depth information about your model together with this one, right? Together with the confusion tree, trying to explain it well. So I can just go back with my print, my classification report, and the classification report is going to take the model, right? It's going to take what we did previously. So what it's going to do is I'm going to take the Y prediction, the prediction that you have, and then the true predictions, which is going to be my test. So this is going to print it perfectly for us and give us a very nice summary. So you can see it's going to give you the precision, right, the recall, and then the F1 score. So this is going to be our labels, and then for the precision, in case you are interested in precision, you can see that if it is predicting on business finance, this is the precision, right? So that is something very simple. Now we have finished a simple model evaluation. Now let's see how to make a simple, let's test our model. Let's see whether it's actually going to work. So we'll be trying to make a singular prediction. So I'll pick in a particular test. So it's going to be my sample example, which is going to be, let's say, building a simple, right, ML web app. Right, so we're trying to see whether this is going to be classified in the right category as a single prediction. So how do we do that? So just as we did here, we vectorize the test, because machine learning models don't understand tests, they only understand numbers. So the first step is that we're going to vectorize this entire stuff. So I can create a function to help us with that. So let's go to vectorize test, which is going to take in the test that we have, right? Then what it's going to do is that we're using the same TF-ID that we have. So my vec going to take the same TF-IDF, TF-IDF, I can't spell, TF-IDF vec, right? Dot transform. This time not fitting, just transforming it, right? Because we have already fitted the dataset, my test. And after I've put in the test, I want you to return that particular my test. So my vectorize to an array, right? So that I'll be able to get it as an array. So this is going to vectorize the entire test for us, right? So if I pass in vectorize test, so test, and I pass in the example 1, it's going to convert this entire stuff into numbers. It's giving us an error. So the reason it's giving us an error is that most of the time it must move through an iteration, right? So I have to go back here and fix it here with this, right? It always goes through with iterations, right? So I must put inside the list. If I run it, now it's going to convert them into a very simple array for us, right? So this is how it's being represented, and this is how the machine learning model is going to understand this particular test. Perfect. So let's see how to make our prediction. So I'll just go back again. Let's equate this one to, let's come back again, equate this one to sample 1. Now pass it here. This is a vectorized test. Then in case I want to predict it, it's going to be my LR model. We have already vectorized, so I can just go with predict. Now pass in my sample 1, right? So that is how to predict. It's going to give us the right prediction, web development. And this is actually a web development course in case we are going to classify this particular test. Perfect. You can also see the probability of this prediction, because we have 4 different classes, right? 1, 2, 3. So what is the probability that it belongs to this, this, and this? And then it's going to give us the highest probability. So the highest probability that is giving us as our final prediction. So to get the prediction probability, can just go with this. So LR, the same thing, model dot predict proba, right? Now pass in my sample 1. So this time it's going to not just give us the prediction, it's going to give us the weight, right? So this is how it's going to be, right? Very nice. So the first one we had, the second one, the third one, and so the highest is going to be the prediction, right? Very simple, right? Perfect. So that is something simple. So in case you want to know what these numbers are, right, you can just use this option. So LR model dot classes with an underscore, then it's going to give us the classes, right? So it's supposed to be classes. Let's go back again and fix it. I spelled it wrong, right? So if I check it out, so this is business. So this is the classes, right? So respectively business finance, graphic design, musical instrument, and the last one was web development, so that you know. That's why it gave us this particular prediction with a 0.88% sure that it is web development. Perfect. So that is one of the ways. Now let's interpret our model, right? Let's be model interpretation. So in model interpretation, we can use a lot of package. You can use li5, which you'll be trying to work with. You can use lime, and also use sharp, right, and the rest. So let's see how to interpret our model. So let's see how to do that. So be using li5, which is the simplest. Explain like AMP5. So I'm going to load my package, my model interp package. It's going to be my package, which is going to be import li5. So import li5. See how I spelled it? as I was saying, my hands is sometimes. So import eli5, and you can use eli5 to help us explain why any prediction is being given. What are the weights that is going to be used to, a model is going to use to assign a particular test, right, or a particular sample to a particular class, right? So let's do that. In case I want to show the weights for each prediction, right? Each prediction. So it's gonna be like this. I can just go back again just to my eli5. Apologies for the noise you may hear behind. Then I'll just go to my show weight, right? I'll pass in my model. So my model is LR model. So eli5 most of the time works with logistic regression, but not naive Bayes. So show weight, it is plural, not singular. So it's going to give us the result. So let me convert this one from this. This is not clear, right? As you can see, I don't think anybody can see this. So I'll just change the theme, go to the settings, change the theme from the dark theme to the light theme, so I'll be able to see the test. So this is going to give us the weight the model is assigning to each and every category. So if he sees these particular weights there, this is the weight, and by that particular weight, it's going to predict, right, and give you the prediction. So that is something simple. So if I come back here and I check it out again, because it has given us, for business, these are all the weights, for the graphic design, for musical instruments, for web development. But these are all numbers. You can't see these numbers, right? So in case you want to see these particular numbers, what they actually represent, right? So we can do the same thing here by coming back again to this option. So in case I want to see the entire stuff, to see the actual words, because I want to see the actual words, right, and their feature of the features, right? How do I do that? So there are two ways to be using the first method, the method 1. So the method 1 is going to be like this option. The first method is going to be like this. So it's going to be my eli5 dot show weight, right? Perfect. Now I just pass in my model. Then we also have another one called features, feature name. So feature name. So the feature names is, if you remember, when we were trying to work on our features, we had something like this: my TF-IDF vec dot get feature names, right? So remember this particular function that we called some time ago. It's going to give us all of these numbers. So these are all the features, right, and their names, right? All the numbers and their names. So if I quit this particular stuff, it's automatically going to know what they represent here. It's too big, so let me reduce this one. It's automatically going to know what these numbers here represent here, right? I'm going to assign them to these ones perfectly. So I can just come back again and do that one here. Copy this and then equate it to this feature names, to this, right? So there is another way. So if I run it like that, now it's going to give us the same thing we did, but it's going to put the names there, right? Very nice. So this thing that we couldn't see, we could not see what these ones means, but now we can see what it actually means, and this is going to help you to know why it's going to give a particular prediction. So in case it sees the word JavaScript, right, WordPress, web, PHP, website, HTML, HTML5, that means that it belongs to web, right? If you see the word like guitar, piano, play, that means it belongs to musical instrument. If you see the words like Photoshop, design, right, it's going to tell that this one is graphic design. The same thing for the trading, right? Trading, financing, accounting, very simple. That is based on, this is very informative to help you know why your model is giving you that particular prediction. The greener it is, the more weight it carries, right? And then the less red it becomes red, that means that it's carrying less weight, right? When I said the same thing is here, but this is in red. So what you are concentrating on is the color here, the green ones. The deeper green means that it's having more weight. Perfect. That is the method 1. Let's see the method 2. And method 2 is going to be like this. It's going to be method 2, right? So method 2 is just going to be the same thing. So eli5 dot show the weights of my model. So it's going to be my LR model, my logistic regression model. Then instead of me specifying the feature name, I can now go with my vectorizer, vec, and I'll pass in my TF-IDF, right, vec. So now it's automatically going to do the same thing for us. So this is method 2. It's just giving us the same thing. Very nice, right? So either you use this method in which you pass in the feature names here, or you just use a vector, right, in which you pass in the vector that you use to vectorize. Is going to assign them perfectly well. That is how to interpret your model, to show the weights and why it is assigning them. Now let's see how to use eli5 to explain why our model gave us this prediction of web development for that particular test, right? Okay, so let's see how to do that. So in case I want to interpret a particular single prediction, it's going to be interpreting a single prediction. So in case I want to interpret a single prediction, remember that when you made a single prediction, let me bring it up again so that you know what we are doing. This was what we predicted, right? So I'll copy this one. This was our single prediction, and I want to be able to interpret it, right? This was what it gave to us. So how do we do that? You can also use li5 to help us with that. I'm going to do my li5. So it's going to be li5, right? Dot show predictions. I can't spell prediction. Then if I go with show prediction, then I'll pass in my model. Always pass in the model first, so LR model. The logistic regression model, so LR model. That's going to be the first thing. I'm going to pass in our test. So what we do is that we pass in our test. We are not passing in the sample. This is the vectorized one. If I go back and I do this particular option here, let's check it. If I go with the sample, this is just numbers, right? But I want to get the actual words to interpret it, so I can just come back again. This is the first method and pass in my actual example. So this was the example, the actual string itself, right? So if I go with example 1 or EX, for example, so this is the test. This is what I want to interpret. So I can just pass it here. Then I'll specify that I want to use this vectorizer, right, to vectorize the entire stuff. So it's going to be my TF-IDF. This is another way of doing it, right? So it's automatically going to use this vectorizer to vectorize our test here, right? Instead of me doing the same thing, then it'll give us the interpretation. So let's run it again. Hopefully it doesn't give us any error. Voila. So it gives us this particular prediction of web development, and you can see from here that that is the only place that is green, right? These are not that green, but this is a greener one, right? And it's given us the reason why it gives us this percentage of accuracy, 0.889, right? Sure, that is web development is because of these features. There is web, there's web, that means it's web development, and there is building, right? And then there's also app, right? So these ways made it to give us this particular prediction. We can also change it to another one. So let's try a different one. Right, you can also try a different in case you want. So let's make something that is confusing. Right, so I'll come back again. Now pass in a test that is confusing. So we'll try with our model first, then you move on to the other one. So we'll have to vectorize it and do the same thing. But let's go straight away. So I'm going to give an example 2, which is going to be this option. Let's call that, instead of building a simple web app, let's call it as something that is not here. So let's call it as Python tutorial for data science, right? Something like that. So this is not web development, but based on our data set, we don't have any place that we had this, so we can also put it here, right? So you can also do the same thing. Let's predict our model first before we move on to this. So I'll just go back again to what we did initially. So LR model dot predict. I'm going to use my vectorize test function. Vectorize test function. Right, and I'll pass in my example 2. So let's see what it's going to give to us. Example 2. Hopefully there's no mistake. This is also web development, right? Because it's still Python and data science. So let's explain it. So in case I want to explain it, I can just change it from here to example 2. And let's explain why it gave us as web development. And see that it's having a word Python tutorial data, right? That's why it gave us as web development. That is how to interpret your model. So you have seen how to build a simple model, evaluate it, and then interpret it. So there are a lot of things you can also do. Now let's move on to how to save our model. So let's see how to save this model, so that it can be use it for productionization, right? So using joblib, so be importing joblib to help us serialize our model. Let's see how to do that. So I'm just going to create a file called my model file, right? I'll pass in what I want to do. So I'm going to open a particular file. So let's call it as my LR model Udemy, right? LR model. You can just give it a full description. LR model Udemy prediction or something, right? LR model course prediction. This is too long, but it is descriptive. And I'll give it the date. Today is 06 February 2021. So in case you're watching from the future, I'll just go with pickle, right? You can also use joblib in case you want, right? So you are opening the file, and this is the file that you're opening, and trying to save our stuff there. Then you must also go back with write byte as byte. Perfect. That's going to be our file. Now let's dump our stuff inside it. So it's going to be my joblib dot, I can't spell joblib. Put dump in my model, which is going to be my LR model, into my file, which is going to be my model file. Perfect. Then after that, I'm going to close my model file. So model file dot close. Right, you have to close it, otherwise, in case you are trying to work with it, it's not going to work. Perfect. So our model has been saved, and next time you can use it to do our task. So thank you for watching this tutorial. So let's rush through the pipeline, the second approach. How do you build a simple pipeline? So you can just use make pipeline to help us with our tasks. That is the simplest approach. You can use pipeline itself. So this is the same way. Another way is going to be method 2 using pipeline. So the pipeline approach is that you're going to combine them together. So you can just go back with, let's say, can call it anyhow. Let's go to my LR CLF, right? My classifier, logistic regression. Right. You can also use, let's say, naive Bayes or linear regression. Right. If you don't use naive Bayes, you can also use that one. Let's call that NV classifier also, right? So logistic would be multinomial. So we have this using a pipeline approach. So as I said, a pipeline consists of transformers, right, and then vectorizers. So this is going to be these are going to be our transformers. These two are transformers. These two are estimators, rather, because taking data and then build a model. These two can also be our vectorizer, our transformer. We're just using TF-IDF. I call that vec, right? We can call it as TF vec, not TensorFlow vec, but TF vec. My TF-IDF vectorizer. See how I'm spelling it wrong. This. So this is another way. So this is going to be our vectorizer, right? So we have gotten our transformer and our estimators, right? So we can actually build a simple pipeline from that. So let's make our first pipeline. So there are two ways of making a pipeline. You can use pipelines also from sklearn dot pipeline, right? Then I'm going to import the pipeline option. So we have make pipeline. We have this make pipeline function. We also have the pipeline constructor. So any of them is going to work, right? So you can use the make pipeline or the make pipelines constructor. So any of them is going to work, right? But I prefer to go with any of them as you wish. So this one you don't define the names. It's going to pick the names for you, and this one you define the names, right? That's the difference between them. So it's going to be like this. I'm going to call it as my pipe for my logistic regression, which is going to be my make pipeline. So make pipeline, I'm passing my vectorizer, right? Transformers first to transform the data. So TF vec. Then the next one is going to be my model LR CLF, right? So we have one for the vectorization and then one for the classification, right? Or model building. So transformers and then so perfect. So we have one for the logistic regression and then for the base, right? So in case I want to actually make a prediction or check the steps within them, I can also do the same thing. So in case I want to check all the steps, I can just go with my pipe or the stages LR.steps. Right, if I go with steps, it's going to give me all the steps there. I can also do, so that it's giving us all the steps. So we have 3 steps there, 2 steps, the transformers and then the estimators. Now one thing about using a pipeline, that since we are using a pipeline, we have to first of all start with the raw data, because we have the transformer there and then the estimator there. So I'll pick the raw data, so I'll copy and paste it to save us time. So I'm picking this one. So this is just the raw features, right? So if I go with string like this, this is not vectorized. This is just the test itself, right? So we see that this is not vectorized. So now if I pass inside my pipeline, the transformer part of the pipeline will work on it. Then the model part, the estimator part, also work on it. So that is what we do. So this is also going to do everything for us. Now if I go back and in case I want to check for the accuracy of this, I can also do the same thing here. Let's check for the accuracy of my model. That's the advantage of working with pipelines, right? So I'll just straight away do this to get the accuracy score, right? I'll pass in score. I'll change this one from train to test, just as we have done in case we're working with a model. Then it's automatically going to pick the right part of the pipeline to give us our score. And as you can see, our data set is the same, right? Which is very high. This is quite high. I'm even surprised. Perfect. So we have seen the difference, right? So you can actually use this one to also do the same prediction. So in case you want to make a prediction, just go with pipe, then let's say nv.predict. Right, then just pass in your test there. Just pass in the test. So example 1, which was the example, right? Without you passing the raw test, and it's going to vectorize it and give you the result, right? So it's giving us an error, right? So it's supposed to be an iterable. So just pass into this one. So that is how to do test classification using machine learning in Python. So thank you for watching this long tutorial. So in case you have any question or contribution, you can just post at the comment section below, and see you in the next session. Stay blessed. Bye.